Today the subject name is compiler design. Now in this subject, previously we discussed about some of the problems related to lexical analysis, that is compiler design, the phases of compiler. Now in this lecture we are going to give a brief overview about the problem solving in the case of regular expressions and finite automata. So these how the automata can be implemented with the help of a given regular expression, and what is meant by regular expression, what are the different examples of regression. In the previous lecture also we have seen, but now in this mainly concentration about the automata given, the automata expecting automata from the for the given regular expression. So let us see with an example each one by one. Now first example, in this one example we have considered array of, that is an index which contains array, that is expression which is assigned, that is equal to 4 plus 2. So how the phases of compiler design, different phases of the compiler can be implemented with the help of the 6 phases. So first phase, that is called as a lexical analyzer phase. So in this phase, what is the elements that is separated for each of the items described for the given expression. Let us say A is to be identified, so that is considered as an identifier. So lexical analyzer separates the units, individual units, into the form of sequences, and gives the result as keywords, identifiers, tokens, non-lexicon, non-tokens, and lexemes, like that, these to be identified. So for example, here in this example, A of index, so that is A is identified, and that is to be written as identifier, and the next sequence, right bracket, left angular bracket, that is left bracket, that is to be identified, and then the variable, that is next index, that is to be considered as one more identifier, and then next right angular bracket, that is right bracket, and then equal to, it is assignment operator, and the number 4 plus is an operator, and then 2. Now all these items, individual items, can be separately described as a process in the lexical, that is it divides the lexicals. Now what is the further phase, that is next phase, syntax analyzer. So in this phase, the expression that is evaluated with the help of a syntax tree notation. This is called as syntax tree or parse tree notation. In this tree notation structure, the identifiers, keywords are to be written as a form of nodes, with the root node, starting the root node, left, right, child nodes. But here, while considering this one, what are the operators to be available, that is to be considered in this one as an internal node has to be considered as internal. Now see here in this expression, A of index equal to 4 plus 2, so equal to that is one, this is an operator, arithmetic expression, assignment expression. So this expression, to the left of this expression, if you observe, the angular bracket, array A, angular bracket, left angular bracket, index, and right angular bracket. So that is to be written as left of this equal to assignment. Why? Because it is available. So what is the right of this one? It is available equal to 4 plus 2. So 4 plus 2 is to be considered as right of. So this part is to be considered as 4 plus 2. So here plus is an operator, that's why it is considered as a node. And to the left of the plus, we are having one node that is to be represented as a number, and another one is 2. So 4 plus 2, that so this is to be given as equal to as an assignment, that is right hand side. And left hand side, if it comes under this one, this is considered A of index. So A is to be called separate with the left child of the node, and rectangular brackets, and index. So these 4 items are to be called individually separately. Now like this, we are going to describe several items with the help of syntax analyzer phase with the corresponding tree node structures. And the next phase of the compilation process in this one, that is semantic analyzer. Here also we are going to describe the notations, but here what is the type of this integer, that is 4 is the of type that is to be decided and resolved here in this one, and 2 also, that is also it is resolved and given a semantic description which indicates it is a integer or floating point number, and that is to be clearly specified. And then this is to be sent to the intermediate code. Here in the intermediate code, it sends the result of the expression, that is if the temporary variable say t, and this is to be assigned with the an index. So that is a two statement. First statement is 4 plus 2 is evaluated and assigned to a temporary variable, and this is assigned to the index value. That is form of intermediate code which by this is of temporary, and then it is sent to the optimization phase, where any sequence further levels of reduction of the code takes place. See here, t equal to arithmetic expression 4 plus 2, that is 6 is evaluated, and the way of index t. So any reductions happens can be observed, and then that is to be reduced lines of code can be written, and that is and also another optimization texts are there available. Since because we have taken only one small assignment statement is to be considered, that's why the length of code is same, but some other cases it definitely reduces the lines of code by implementing the optimization phase. That is, we can also write a 2 line with instead of a single line of the statement by implementing this optimization process. And then final phase, code generation phase. Here we are going to deliver a machine code by implementing by usage of this machine instructions. Say for example, a register, we are going to take a register, and this is to be passed with the index variable, and then we are going to shift left, apply the shift left with the register or not, and then the contents, what is the index that is available, that is to be shifted with the by applying this or not, and then it moves address of a of r1 comma 6. Or you can also use these lines of code with instead of this 3 lines. The index to be moved with the register or not, and then 2 will be called with the register or not, address of operand r1, then add both the registers r1 and r2. Why? Because 4 plus 2, and then the 6 is to be separated with the register, and then that is to be moved with the a of n. So like this, an assembly machine code is to be generated. Now, coming to this example, that is regular expression with finite automata. See here, the given expression is b plus a star, b plus a star, a b plus a within bracket and outside star a star. So this is the given regular expression, and we are going to convert this one into an automata notation procedure. So what is the finite automata for regular expression is, in this case, suppose if only one input is available, that is a, then we are going to construct a finite automata of the representation such as initial state with q0, q0 or q1, first state q0 or q1. Then what is the input that is supplied to the user, that is the a only one input. Then it reaches your states, final state say qf, and then it is to be surrounded with the double circle. So this double circle representation indicates that it is reaching to the final state, and we are going to say that whether the state is accepted or not. So here, since expression is only a, so we can say that it is accepted by finite automata for the given expression a. So other than a, no regular expression can be accepted in this case. Suppose if you want to write an automata notation, only the expression a, b is to be implemented with the help of this automata notation. Then we can write a three state notation such as q1, q0, q1, q2. So here q0 is an initial state, q1 is the second state, q2 is the final state. Now, what is the given expression ab? So A is one symbol, B is another. So first we have to read the input from one state Q0 to Q1, Q0 to Q1 with the input A. We are going to read one input symbol A, and then next input symbol is B. So from Q1 to Q1 to another state say Q2, and reading the another further input B. Then after that there is no input is available. After B there is no other input. So we can stop this procedure. So where we are stopping, that is to be considered as a final state. And where we have started, that is to be considered as a initial state. So this initial state can be represented as a arrowhead pointer to this particular state. So small arrow is to be represented, indicating that where we are going to be start with the expression of this one. So state expression Q0, first state, start with input A, and that is Q0 with input A. On input A reaching to state. What is state here? We are going to receive Q1. And then from Q1 with some input B, and reaching to other state Q2. So here we are going to stop. Why? Because double circle reached. If there is further input is available, then we can. So this is a AND operation, AB. Suppose if the expression contains OR operation, that is A plus B. If the expression contains, it is an AND operation, A and B. But if the expression contains, regular expression contains A plus B, then we can write a notation of the description of finite automata, such as first initially we can take the Q1 as the state, Q1 state. From this Q1, first input is what? A. So you can read a notation that is input A receiving the input and then reach to the final state. So final state is this one. So here we are having the two options. So I may start with start with state Q1 and reach to the final state with the help of either A or B. So that's why one arrowhead is pointing to Q1 to Q5 with A, and one more also available arrowhead pointer with B. So here Q1 is the starting state. With the help of input A, I may reach to the final state, and I may also reach the final state with the help of B also. So A or B are the further. But in the previous one, we are going to receive the input A and along with B, then only I am going to reach to the final state. Here the exception, here in this expression, either A I am going to reach the final state or B also I am going to, either of them is allowed. So that is to be represented as a regular expression A plus B in terms of finite automata representation with the states such as initial state Q1 with input A reaching to the final state, and either or otherwise the input B reaching to the final state. So like this, these two are main important roles for doing the applications of this regular expression into an automata representation. So sometimes you can also write a representation A plus B whole star. So in this type of regular expression, indicating that where star represents 0 or many. 0 or many. So here A plus B are indicating that we are going to write either A or B, but this we are going to write state, one state with representation of A. That is A star also we can write. A star indicates that self loop with repetition of A's. Where if A plus B star means same A plus B star indicates that instead of A plus B star. Instead of A plus B is available. So A star means we are going to write this one. So that's why you can write A comma B. That means I can start with A and many number of A's, or I can go with B also. So these two cases are allowed with the help of this representation. So that is the various expressions for representing. Another one is A star. A star is the expression. So here we are going to till now have used an express finite automata with a plain finite automata without using epsilon moves. But here we can also represent a finite automata with the epsilon representation. That means epsilon representation indicates that empty move. That means empty move. a state from current state to the next state transition possible with the empty move also in case of NFA, whereas in case of DFA, empty moves are not allowed. DFA, this empty moves are not allowed. That means if epsilons are available, then it is not considered as a DFA. It is considered as a NFA only. So empty moves not allowed in case of this DFA. So this diagram representation indicates that it is an NFA, where the epsilon moves are allowed, indicating that here first initially we can take a Q0. With epsilon move, I may go to Q1. With another by consuming input A. Here there is only one input A, but reaching to the state Q2 after that epsilon. So this is to be repeated how many times? So plainly we can write with epsilon with Q0, Q1, that is epsilon, Q2 the A followed by another state Q2, and then epsilon Q3. That is the representation for NFA. NFA for one epsilon NFA. This NFA is epsilon NFA for regular expression A, simple regular expression A. So this is the diagram to represent this one. Whereas the given expression is not simple A, it is A star. A star indicates that several number of A's. That means it should satisfy epsilon, A, double A, triple A, like that one. It is the set of strings which forms this language L. So this is the language supporting the all kinds of string with A star. Now we have drawn already A, but what about A star means? So repetition of A's can be possible by applying an epsilon from Q2 to Q1 and also epsilon Q0 to Q3. Then this epsilon is possible without giving any input, and A also, these two cases satisfied, and double A by implementing the self loop. That means Q1 to Q2 A and then epsilon A means epsilon Q0 to Q1 and then Q2 and then Q3. So Q0 to Q1, what we are getting? Epsilon. Q1 to Q2 by input A, and Q2 to Q3 input is epsilon. So epsilon A, epsilon will get reaching the A. And suppose if there is no input is given, then directly Q0 to Q3, that is epsilon. That is also possible. So these two cases are available. Next case is double A. This string is possible with the help of the states Q0 to Q1, then Q1 to Q2, again Q2 to Q1, again Q2 to Q1, epsilon A and then epsilon, and then Q1 to Q2, Q2 to Q3. It means A, epsilon. So that is epsilon A, epsilon A, epsilon means double A. So this is the case for like triple A. So for the repetition of several number of A's, so epsilon NFA, what we can do, we can make a transition, that is epsilon move from Q1 to Q2, Q2 to Q1 with epsilon move. So that it is a self repetition of A, epsilon A several number of times. That is 2A's, 3A's, 4A's like that. So that's why it is. Where this one is to be Q1 to Q3 representing an empty move, epsilon move, first starting string epsilon move, satisfying this condition. So that is the main description about A star into a regular expression. That is a regular expression A star can be represented with help of NFA notation with epsilon. So without epsilon also we have represented previously in the previous diagram. Now another example, which is another problem which is used for solving the expression 11 plus 0 star 00 plus 1. So here the automata can be represented in notation that is Q0, Q1. But here followed by 1, 1 indicates that it is previously also have seen AB followed by Q0 with Q1, another state Q2, Q2. So here input is 1, here is input 1, or 0 also. or 0 R0 means Q2 0. So input either 1 1 or 0. 1 1 followed by many number of ones also. So here the possibility is many number of ones. So that's why here that is to be calculated with Q0 to Q1 with 1 and Q1 to Q0 with 1 and self loop if we make, then it satisfies the condition of this. And whereas 0 0 with the replacement 7. See Q0, Q1, 0 0 and then repetition of ones 1. So in this way we are going to uh, get this expression with the two notations and we can make combined together. It is an AND operation, so we can make the AND with this one by making this epsilon symbol so that these two diagrams. So here we are going to give several states and with epsilon transitions also, and the two states corrected by epsilon transition uh, cannot be collapsed into one state. Why? Because if it is epsilon is added, then we cannot further break down into steps. So that's why epsilon is to be included. And then the state that is 110 if the string, then we can say that it is accepted. And but this matching expression or not, that is to be verified. So any number of ones, either 1 1 or 0 star, and 00 or 1 star. So 0 1. Like that, there are several set of strings that is to be possible in this example. And also we can give a brief overview of this epsilon NFA by using this expression A star plus B star. So previously we have considered A star with 0 or more number of A's representing star notation. See here initial state is, start state is Q0 only. But I may go to a phase that is at the left hand side with one path, and this path leads to the procedure of that is ending with say here epsilon Q0, from this Q2 and then A and then epsilon and then epsilon. So here epsilon dot A dot epsilon. Now what is the here final state we are getting A only. And if you want, and if the repetition of A is for this purpose, we are going to implement this Q2 to Q3. Previously we have drawn how the star is to be repeated for A star. So the same way here Q2 to Q3 and Q1 to Q4. Q1 to Q4 representing that plain epsilon. Individual epsilon is to be, that means without crossing any input A, direct epsilon is to be reached. Whereas for other remaining possibility string, that means epsilon A, double A, triple A, like so on, etc. So this is the set of strings that is possible for this automata. So epsilon reading only individual string. So that is Q1 to Q4. Suppose if the input string is A only, then we can say that Q1 to Q2, then Q2 to Q3 and Q3 to Q4. That is the reading. Whereas AA represents Q2 to Q1, Q2, Q3, Q2 again, Q2, Q3 and then reach to the Q4 and come to the Q9. So this is the end point, final step. But from starting to the Q0 to Q9 left portion, one side top portion, this describes about the A star only. And whereas B star represents the right bottom portion of this Q0. That is bottom portion means Q0 to the another end. Q0 with epsilon one end and Q0 with epsilon another end. So second end, another end from Q5, if you receive the input with B only and then reach to Q8 with epsilon and then reach to the Q9. So either of them reach to the Q9 only. But here individually if you write this side, that is A star, otherwise B star. So both the combinations we can say either A star or B star. If the input received is epsilon A, then we can write. Suppose if the input received is epsilon B, double B, triple B, etc. So then we can process the input, this is epsilon B, Whether it is A or B, for individual epsilon we can process, but for B, then epsilon B followed by Q7 to Q8 epsilon and Q8 to Q9 epsilon. So that is the required finite automata with epsilon procedures for the given regular expression A star B star. So like this we can generate an automata notation for the different individual expressions also. For example, if the expression is given here, suppose B or AB star followed by AB star whole star. This is the given expression. So for this I can give a finite automata. That means this automata is going to accepting all the strings, even number of A's. Why? Because here two A's are there. If the number is repeated also, maybe there is even if the star is applied, then also 2 square, 4 square, like that to get the 2 power 1. So 2 A's are there. That's why we may get generate even number of A's only. Suppose if there are no 0 A's, if there, that means this power star, there is no, that is 0 indicates epsilon. That means Q naught is in the, if it is not a plane NFA, then we can say that it is in the same state. That means Q naught state only. That means without receiving any input, the whole power 0 indicates that it is epsilon. So that is to be in the same state only by reading this input. That is B or this one. That means B or either. So B sorry. So that's why you have reading the Q naught as the current state and supplied input is B, reach to the state Q naught. That is which is the final state. Suppose if only one A, then it will go to the state from Q naught to Q1. If the starting state is and final state both are same at Q naught only, so we have started at Q naught and received the input A, received and Q1. And the string here it is not accepted. Why? Because it is only one A. If it is only one A, then this comes under odd number of A's. Odd A's. For 2 A's, then the position will change. Why? Because Q0 to Q1 and then Q1 to Q2. This is the one position. We received one input A and then after processing another input A. So A Q0 with Q1 and Q1 with Q0. So from Q0 to Q1 I am receiving with input A and then from reaching to the Q1 state. Q1 state with input further input A reach to the Q0. Q0 is the final state. So that's why the string received here is AA. That means 2 A's. So they accept it will accept the string. That means any number of A's with 2 or 4 several A's, it is 4 or even number of A's only it is accepted. Remaining cases it is to be developed based on the self loop that is implemented with Q0 and Q1. So this is the finite automata expression which describes the regular expression B or AB star followed by star. Simply if the expression is given as AB star, then we can represent a language with a set of strings A followed by B star. That means here one A is available, but B's are many B's are only one A followed by several B's. Several B's means maybe 0 or more B's. 0 or more number of B's. So this is the given regular expression. So for this we can write a language saying that how many A power B power 0, that means epsilon, B power 0, A B power 1, A B power 2, A B power 3. So this is the language to be implemented. Say L equal to. Now L equal to B power 0 is epsilon, A into epsilon is A only, A B power 1 B, so A B power 2 to be considered in the expression as B followed by B, and B power 3 consider the expression B followed by 2B, B followed by B, Like that the expression continues. For this the automata can be represented as, so for each string if you observe the first letter is symbol is A only, followed by several B's. So that's why we have taken one state, that is initial state, and final state with the final state, this is the double circle representation. So in this the input is A. So why? Because each string input is A only. So we have compulsory use the starting with the state X, reaching the reading the input, and then further processing to the state. Now we can stop, or if it is a simple string. Suppose if the string is not stopped, any other further symbols are there, then we have to read one more. So that reading is to be done with the help of a self loop with input B. Self loop with input B, so that I can go for several number of B's. One time B, or next time 2 B's, and next time 3 B's, like that. I may receive the input several number of times based on. So that is the automata is valid for starting letter A followed by any number of B's. The letter A followed by any number of B's. That is the given expression. So this expression, the automata generated is two states, x comma y. From x to y input is to be supplied A, and y the self loop B is to be considered. So like that we can generate, we can find this automata for the given expressions. And also, for example, A power n, that means this is the similar model which is to be described previously. A power n means n greater than or equal to 1. So here there is no epsilon. So A power 1, A power 2, A power 3. So individual A followed by A followed by A followed by A, 3A's, 4A's. So like that the language is to be considered. For this language, we have to implement this. So here the number of A's are each string must and should contains at least one A followed by several number of A's. So in that case, we are going to write an input A between the two states, and then the several A's are represented by the self loop A. Suppose if there are more than one, in that case, suppose for example A power n, B power m. So here at least one A followed by any number of, at least one A followed by number of A's and followed by number of B's. So for that case, we have extended the one with one more transition state. With A, for first A input is A, x to y. Then the self loop that is implemented is small a, and then further extended with the input B, it receives the, and then so here A, like that A, not only A, several number of A's, A star, and then followed by B, then followed by B star, several number of B's. So the expression result contains number of A's with 0 or more and number of B's with 0 or more. Even if it is 0 also, so at least one A will be present, and for the second case, at least one B present. So the minimum string substring that is required is A followed by B. So that is the first string. And in the second string, A, B. So first A and followed by any other string is required, A power 0. So here A power n is n equal to 1. So if A power n, it is not A power n. A power n. So if it is A power n, that means A power 1 followed by B power m. B power, so here B power m means B power 1. So A, B. Like this, you can also have several A's. That means A power 4. This describes A power 4, n equal to 4, and B power 2. So you may apply n and m with different combinations. So n equal to 1, m equal to 1, so 2, 2, 3, 3, or 1, 2, 3, 4. So like that, different combination of A's and B's possible. But the minimum substring is AB without any repetition of A's and B's. But if any repetition of A's possible, then that is occurrence before B only. So that's why in the while In the Y state, we have described a self loop A, and at the end, B power M means at the end of the scenario, this will be 0. So that is the given automata for the expression. So all the things which are available from this can be available is the book, that is Compilers and Techniques. Thank you. We'll come up with the next one session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.